Hey guys, so today we're going to be dealing with how to calculate the unknown side in right angle trigonometry where we have word problems. Now before we continue with this video, you need to be very comfortable on how to label a triangle, on how to identify which trig ratio to use, and how to use equations to calculate the value of the unknown. So the aim of this video is to be able to calculate the value of an unknown side in a right angle triangle by using trigonometry by first extracting information from a word problem. That is our learning intention for today. Now, we know we can find the value of an unknown side on a right angle triangle when we have at least one angle and one other side. And we use our trig ratios, SO, CAR, and TOA, in order to do that. Let's jump into the first example. Now you should always read the question 3 times when you have a worded problem. The first time you read the question, you should identify what topic that question is a part of so that you can go and recall all the information of that topic. Now we already know that these questions have to do with trigonometry and calculating an unknown side. The second time you read a question, you should extract all the information that you are required to and draw a diagram if necessary. You should then answer the question, and then before you move on, you should read the question one last time to identify, have you answered what the question's asking, and have you rounded off where required? So let's have a read of this question. It says, a ladder leans against the wall so that the angle it makes with the ground is 56 degrees. Its base is 3.6 meters from the wall. The question is asking us to find how far does the ladder reach up the wall to the nearest centimeter. So let's draw a diagram. We have the wall, we have the ground, and we have a ladder leaning from the ground up to the wall. That's the first part. Then we go through and we identify what numbers or information the question has given us. So the question says, the angle the ladder makes with the ground is 56 degrees. So that means that angle there, ladder, ground. Not ladder and wall, ladder and ground. If the question said, what angle does the ladder make with the wall? Well, that would be up there then, but it doesn't. It then continues to say, the ladder's base is 3.6 meters from the wall. So there's the ladder's base, and it's 3.6 meters from the wall. The question's asking us, how far does the ladder reach up the wall? So we're trying to find this distance here. Now, if we redraw that as a triangle, a right angle triangle, we can then see the information in the black given there. Step number 1, label the triangle. So opposite the right angle is always the hypotenuse, but there's nothing there. Opposite the angle is the opposite side, and the last side left is adjacent. So this question here is using O and A. So we know we're using tan, TOA. We identify the trig ratio we use, tan theta equals O over A. We substitute the values we know in. We know that tan theta, the angle is 56 degrees, the opposite side is X, and the adjacent side is 3.6. And now we use equations to get X, or the pronumeral, by itself. The opposite of divided by 3.6 is times 3.6, so we do that on both sides. Now, in the calculator, we have left X equals tan 56 times 3.6. That's what was left from the question. When we type that in the calculator, we get a decimal that does not terminate, and we know we have to round off anyway. So the question says to round up to the nearest centimeter. This is 5.337 meters continued on. So to round up to the nearest centimeter, I look at this 7 and I'd round that 3 up to a 4. So now I have the distance from the ground up to where the ladder reaches the wall is 5.3 meters, 2 decimal places, approximate. Let's move on to the second question. The second question says, find the height of a flagpole if a supporting wire from the top makes an angle of 47 degrees with the ground, and the wire meets the ground 4.6 meters from the base of the flagpole? Well, here, this question is a little different because they've told us what they want us to find at the beginning of the question. It says find the height of a flagpole. So let's draw the flagpole, let's draw the ground, and let's draw the supporting wire. Now the question says that the wire makes an angle of 47 degrees with the ground. So the 47 goes there and is 4.6 meters from the base of the flagpole. From the base of the flagpole, it's 4.6 meters. It wants us to find the height of the flagpole. Remember, the wire is starting from the top of the flagpole, not halfway down or somewhere in between. So we can find that whole x value there. Step number 1, label the triangle. We have our angle there, so you have opposite. Now remember, there's nothing on hypotenuse there, so we have opposite and adjacent. Now, which trig identity uses OA? Well, we know it's tan. So, tan theta equals O over A, and order here is so important. Substitute the values in to the syntax, and again, we need to get the pronumeral by itself. So the opposite of divided by 4.6 is times 4.6, and I times 4.6 on both sides. I'm left with x equals tan 47 times 4.6. Now when I chuck that in a calculator, again, I get a decimal that doesn't terminate, or a whole integer. So I need to round that off. But what did the question ask me to round off to? Again, the question asked me correct to the nearest centimeter. So I look at that 2, and that remains as a 3. So the height of the flagpole is approximately 4.93 meters, correct to 2 decimal places. Hopefully you're getting the hang of this. Let's do one more example involving some shapes. So here, the question says, an isosceles triangle has a base of 18 centimeters and a base angle of 72 degrees. What is the height of this triangle to the nearest centimeter? Now here, we need to recall the information we know about isosceles triangles. We know with isosceles triangles that both the two top lengths are the same and both the bottom base angles are the same. Now, to use trigonometry, I need a right angle triangle. So I know that if the height is exactly in the middle of this base, because these sides are the same. So if I make this a right angle triangle here, the bottom of this triangle is not going to be 18 anymore, it's going to be half of 18. That's where the trick comes into play. So half of that is going to be 9. The 72 is the base angle, and we're trying to find the height of this triangle. So let's label the triangle. Right angle, opposite the right angle is hypotenuse, there's nothing there. Opposite the angle is opposite, and the last side is adjacent. And again here, we're using tan because it's tawa. So we substitute into the syntax. Tan 72 equals, what's the opposite side? Well, it's an x, so that goes up the top. And the adjacent is 9. Again, to get the pronumeral by itself, I need to do the opposite or inverse of divided by 9, which is multiply 9 on both sides. Now, in the calculator, I'm going to type tan 72 times 9. And again, I get a non-terminating decimal, or a non-integer. So here, this is already in centimeters. So 27.699 centimeters to the nearest centimeter, that 6 makes that a 28. So the height of this isosceles triangle is approximately 28 centimeters to the nearest centimeter. Hopefully those examples helped you. I have a few questions that I'd like you to try yourself. Pause the video and give them a shot. Okay, you should be done by now. Check your answers off. Hopefully you got them all right. If not, go through, watch the video again, pause it where you need and create some notes. Till next time, take care guys.